All right, should be good. Okay. Okay, well, hopefully you got this down by now. Basically, what you just need this, and then I know you don't have graph paper, but if you were to just make like an XY plane in your notes and just have like -1 to 0, -1 to 2 on the y-axis, this will help us start to create a slope field. So a slope field, like you can make this as big as you want. I mean, you can take this coordinate plane, if this is the origin right here, you can make a slope field as big as you want. On the stuff that we're going to do on these examples, though, we're just going to kind of like confine it to this area around the origin. Okay. So we have an equation, dy dx equals x plus 2. Something that's really important to know is dy dx could mean a couple things. Dy dx also means y prime, right? It means the derivative of y. So you could write the equation like this. Kind of the more important thing today for these slope fields is y prime also means slope, right? Derivative also means slope at a certain point. So you could write m for slope, right? Y equals mx plus b. Think of m as your slope, is equal to x plus 2. So dy dx and y prime and m all mean the same thing, slope at a point. Okay. And then so what you would do from there, depending on how your chart or your graph looks, is you set up an x, y, m table. And then you can start getting your slopes at certain points. Okay. In this case, though, for this is a really basic one. We just have an x. We don't have, right, in all of our, we don't have a y in the equation. So we don't have to fill this column in at all for this example. We're just filling in x. Okay. So we're only focused on these values down here on the x-axis. So let's plug those test values in, -1, 0, +1. And let's find what our slope is at those x values. So basically you take each one of these, plug it back into the equation. -1 plus 2 is a +1. 0 plus 2 is 2. 1 plus 2 is 3. Okay, so these are the slopes at those points. So the way to make this slope field is you go to these points on the x-axis, wherever x is -1, my slope is 1. Okay, now you end up kind of estimating these slopes, but as a general rule of thumb, if a slope is 1, make it like 45 degrees, and then you can base everything off that. If it's less than 1, you flatten it out. If it's more than 1, you steepen it up. So I'm going to start at -1 and say my slope is 1. So let's make like a 45-degree slope at -1. And actually, wherever my x is -1, my slope is going to be 1. So wherever my x is -1, I'm going to make that 45-degree slope right there. Okay. Then I can go to my next value where x is 0. My slope is 2, so I can base it off this and just kind of steepen it up a little bit. So I could say like anywhere x is 0, go like this. Say that's a slope of 2. And then anywhere x is 1, my slope is 3, so maybe even more steep. It's kind of drastic. Later in these slides, we'll get into like how to actually sketch a curve through this. But for these first couple slides, we're just generating like slope fields and slopes at certain points, okay? If you were to take the integral of this though, x would turn into x squared over 2, which would make sense that be some sort of parabola here, right? The antiderivative of this would give you a parabola, which would make sense that this is curving like this, okay? Let's have you guys try one with, now this one only has y's. So I'll get you started on the table at least, and we have you go from there. So I'd have x, y, and m. nothing gets filled in for your x's. Now your y's, you're going to have to use these numbers now, because this is your y-axis. So you'd have -1, 0, 1, 2. And let's see if you can kind of take it from there. I like the last problem, just going the opposite way, sideways instead of up and down. Remember, if it's a zero slope, it's just a flat line. All right, so again, just pay attention to, like, you're doing the y's now. So wherever y is -1, it's 0. Wherever it's 0, it's +1. So you're going this way now instead of up and down. All right. Those are obviously like really basic ones. We'll try one or two more that's a little bit different after this. Okay. All right. Let's try an equation where you have x's and y's. I'll try to give you some shortcuts on this. It could turn into a pretty long process if you're not careful. Okay, I'm going to start with x, y, and m. All right. So the deal is, like, before we just had x's, so we only had to worry about these three numbers. We just had y's, so we only had to worry about those four numbers. But if you have x's and y's in the equation, now you got to worry about like every single one of these points, which could make your chart really long. But the shortcuts you can take is pick some points that you can just do right off the bat in your head. Like if I plug in a 0 for x, 0 times anything is 0. So if I plug in a 0 for my x, my slope is going to be 0. So wherever my x is 0, my slope is going to be 0. That'd be like a really quick thing you could fill in. Another thing is if I plug in 0 for y, right? Anything times 0 would still be 0. So anytime my y is 0, I'd have a 0 slope. So that kind of narrows it down to only a few points that you could check. So let's try like this bottom corner here, -1, -1. Negative and negative make a positive, but you still have this negative hanging out there in the front. So that would still be -1, right? Basically negative, negative, negative makes a negative. So then you'd have -1 would be this way now. And then maybe let's try this one. So let's do -1, +1. Okay, this would be 1 times -1 is -1 times another negative would actually make a +1. So this actually goes in this direction. And from there, and again, like you don't have to make this next line in this chart. You could just kind of say, all right, -1 times 2 is -2 times negative would be a positive. So some of these, like once you get to a certain point, you can start to kind of do it in your head without referring to the chart every time. Okay, let's try a couple more over here. We've got, well, this would be the same. This would have a 1 here. I'm looking at this bottom corner right here. I got a 1 and a -1. That would also be a positive, right? Negative, and that negative would switch it to a positive. So then this would look like this. And then 1 and 1 with a negative in front of it would actually turn this to a -1. And they could fill in your last one. Essentially, it would all look like this when you're finished with it. So the last one up here would be a negative. All right. Okay. Any questions? There is one type of problem where you're going to get an undefined slope. Let's have you guys start this. This will be the last one you try, and then we can do a little practice on our own. So notice you have a denominator now. So there's going to be some points where you get undefined. All right. Before you guys go too far, just notice that if you were to plug 0 into the denominator, if you were to plug in 0 for a y, anything over 0 would be undefined. So when you get undefined, just make a line straight up and down that looks like that. So undefined slopes are vertical. Just make them straight up and down. And then you could probably work through the rest. So that would end up, final answer would look something like this. Whenever your x is 0, you'd have a flat slope. Whenever your y is 0, you'd have an undefined slope. All right. Okay, last thing I want to show you guys, and you don't have to write this part down because it's just a huge slope field. But on the back of your sheet that I'm going to give you, it asks you to sketch an approximate curve along the slope field. To do that, it all depends on where they're telling you to start from. So in this case, it gives you a slope field and it says use the initial condition of 0, 0 to sketch a smooth curve to the solution. So whatever point they give you, that's the point you start at, right? And then to sketch the curve, think of this as like the wind pushing you. You don't want to like cross over these. You just let it push you in that direction. So in this case, I would follow, kind of go in this alley here, and then I wouldn't want to cross over these, but the wind would just kind of flatten me out and push this way. And then you kind of do the same thing the opposite direction, just kind of go through that alley that it's taken you from there, okay? If it said start at 0, -2, then you would start like right here, and you would do the same thing, okay? So approximate curves or smooth curves, the approximate solution, okay? All right, let me stop